Hi students, have a nice day. In this section we are going to discuss about the organic chemistry. As earlier we discussed, chemistry is divided into different branches to study the compounds. Inorganic chemistry, physical chemistry, organic chemistry, pharmaceutical chemistry, analytical chemistry. In the case of inorganic chemistry, the chemistry which deals with the substance or compounds from the minerals, that is from the non-living things. Organic chemistry is a branch of chemistry which deals with the carbon and its compounds, hydrocarbons and their derivatives. So this branch is dealing with the substance from the living things, from the plants and animals. As earlier, scientists strongly believed that a hidden force behind the formation of organic compounds, and that force is called a vital force. Okay, so Berzelius in 1811, Berzelius proposed vital force theory. What is a vital force? There is a hidden force, an unknown force behind the formation of organic compounds. The compounds cannot be synthesized in the laboratory because the vital force is essential. What is vital? It's related to life. Okay, vitamins or vitamins. So vital means it's essential for life. So vital force theory strongly believed that organic substance or organic compounds cannot be synthesized in the laboratory. And the Berzelius theory is famous up to 1828. In 1828, his disciple, Frederick Wohler, W. Wohler. Frederick Wohler synthesized urea in the laboratory. That's a big blow to the vital force theory. In 1811, Berzelius proposed that a hidden force, a vital force behind the formation of organic compound. Organic compound cannot be synthesized in the laboratory. But later in 1828, Frederick Wohler, this is proposed by Frederick Wohler in 1828. He synthesized urea from the inorganic compound ammonium cyanate. He evaporated ammonium cyanate solution. This is ammonium cyanate. He heated the solution and it is evaporated. He gets NH2CONH2. It is urea. As earlier, urea is collected from the animals, from the urine. And later in 1842, Kolb synthesized acetic acid, CS3COOH, from the elements carbon, hydrogen and oxygen. So in 1842, Kolb synthesized acetic acid in the laboratory from the constituent elements carbon, hydrogen, oxygen. So these are the death blow to the vital force theory. The ground of the vital force theory is questioned. and the new branch is fastly developed and is called organic chemistry. Nowadays, 95% of organic compounds can be synthesized in the laboratory. Okay, 95% of organic compounds can be synthesized in the laboratory. And now you know that many hormones, many chemicals, many medicines, many proteins can be synthesized in our laboratories. So the study of carbon compounds, the study of carbon and hydrogen, collectively called hydrocarbons, and their derivative is called organic chemistry. Are you clear? So organic chemistry is a branch in the chemistry. Let's discuss how the carbon form this much amount of compounds. Nearly 3 million compounds are formed by a single carbon atom. Okay, 30 lakhs compounds are identified by the scientists. Out of these 3 million, 95% is synthesized in the laboratories. Okay, so why this carbon form this much compounds? That is another scenario. The carbon have unique character. Carbon has uniqueness. What are the uniqueness? You learned in the lower classes. The first uniqueness is smaller in size. Okay, carbon is smaller in size. In the 14th group, the first element carbon, it has only 2 shells, first K shell and the second L shell. And the 6 electrons are distributed in the shell 2, 4. The correct electronic configuration is 1s2, 2s2, 2p2. These things you know that. So the first uniqueness of the carbon atom is smaller in size. And the second one is tetravalency. Carbon atom is tetravalent. That means carbon can form 4 bonds with the other atoms or with the carbon itself. And the third important uniqueness is the catenation. What is catenation? The self-linking property of an element is called catenation. Okay, what is catenation? The self-linking property of an element is called catenation. Okay, so carbon has higher catenation ability. It forms linear chain, branched chain, cyclic compound, etc. So carbon has some uniqueness. The uniqueness of carbon atom. Uniqueness of carbon atom. First one is smaller in size. Second one is tetravalency. Tetravalency. And the third one is catenation. What is catenation? Self-linking property. Self-linking property. That means carbon is linked with the carbon itself, and also the other branched chain also formed. C, 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 C. Okay, carbon is tetravalent, and this carbon forms linear chain, branched chain, also cyclic compounds. So these are the uniqueness, the important uniqueness. So carbon forms linear, branched as well as cyclic chain. That is catenation. Okay, so catenation means the self-linking property. The self-linking property is highest for carbon atom. Are you clear? Yes. And the fourth point is, okay, I write here, the fourth point is formation of multiple bond with the carbon atom as well as other atoms. Multiple bond formation. Carbon can form multiple bond with the carbon atom as well as other atom. For example, C double bond C, C triple bond C. Okay. Then a C double bond O, C triple bond N, C double bond S. Okay. So carbon can form multiple bond with the carbon atom as well as with the other atom. This is another uniqueness. Okay. The uniqueness of carbon atom. And the fifth uniqueness is isomerism. The fifth one is isomerism. Or they can form isomers. What are isomers? Compounds have same molecular formula but different structural formula. Okay, are called isomers. And the phenomenon is known as isomerism. So these are the important uniqueness of carbon atom. First one is smaller in size, tetravalency, catenation, then multiple bond formation and isomerism. How carbon is tetravalent? In the case of carbon atom is the electronic configuration is 1s2, 2s2, 2p2. But carbon in the excited state, you know that. In the fourth chapter we study hybridization and bond formation. Carbon is in the excited state 1s2, 2s1, 2p3. That is 2s1, 2px1, 2py1, 2pz1. Now carbon having 4 half-filled orbitals. S, P, X, Py and Pz. And that is explain the tetravalency of carbon atom. And also another important points are carbon having higher electronegativity in that group. In the 14th group, carbon has higher electronegativity. Okay, high ionization energy in that group. So main points are smaller in size, tetravalency, catenation, multiple bond formation, isomerism. Due to smaller in size, it can form multiple bonds, p-pi bonds. Okay, so these are the uniqueness of carbon atom. Next, we discuss the hybridization of carbon atom in hydrocarbons and their shapes. Okay, already we know that carbon has 3 different hybridization, sp3, sp2 and sp. Let's discuss some organic compounds having different hybridization. Okay, so first one is sp3 hybridization. sp3 hybridization. In sp3 hybridization, the carbon atom is singly bonded. All the bonds are singly bonded with the other atoms. For example, methane. H, 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 H. And the shape of the molecule is, you know that not square planar, it is tetrahedral. It is tetrahedral shape. Carbon atom. 4 hydrogen atoms are pointed towards the apex of a tetrahedra. And the bond angle is 109.5 degree. Exactly 109 degree 28 minutes. Okay, so then next is ethane, C2H6. In that, two carbon atoms are covalently bonded by a single bond and 6 hydrogen atoms. 6 hydrogen atoms are joined to 2 carbon atoms. 3 in one carbon atom, the other 3 in the another carbon atom. This bond angle also 109.5 degree. This bond angle also 109.5 degree. 2 tetrahedra are joined. Okay, 2 tetrahedra are joined in the case of ethane. So, in this case, the number of sigma bonds, you know that. How many sigma bonds are there? The number of sigma CC bond is 1. And number of sigma CH bond is equal to 6. 3 in this carbon atom, 3 in this carbon atom. Here, only one sigma bond, it is sigma CH 4. 4 number of sigma CH is there. Okay, the number of sigma bond is 4 here. And what about in the propane? In propane, the 3 carbon atoms are joined. And the carbon valency is tetravalent. So here hydrogen, 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 hydrogen and hydrogen. Okay, so 3 carbon atoms, the tetravalency are maintained. How many sigma CC bond is there? You just count it. 1, 2. So 2 sigma CC bonds are there. How many sigma CH bond is there? 1, 2, 3, 4, 5, 6, 7, 8. 8 sigma CH bond is there. The formula of the compound is C3H8. Here it is C2H6. Are you clear? Okay. So this is about the sp3 hybridization. In sp3 hybridization, the carbon atoms are joined by, or the carbon forms a single bond with the carbon atom or with the other atoms. Are you clear? Yes. Then next we move to the sp2 hybridization. So all these things are very important. Next is sp2 hybridization. Remember that? sp3 hybridization, the geometry or the shape of the molecule is tetrahedral. Bond angle is 109.5 degree. Carbon atoms are formed only single bond with the other atoms or carbon atoms. Okay, the next is sp2 hybridization. sp2 hybridization. In sp2 hybridization, we know that one s orbital and two p orbitals are undergoing hybridization, and one of the p orbital is do not participate in hybridization even though they contain one electron. That orbital laterally overlap with another p orbital of carbon atom or with the other atoms. Okay, so the shape of the molecule, you know that the hybridization is sp2, 3 hybridized orbitals and 1 unhybridized orbital. What is the shape of the molecule? It is trigonal planar. It is trigonal planar or triangular planar. Okay, trigonal planar or triangular planar. And here sigma bond as well as pi bonds are formed. For example, C2H4. In C2H4, the carbon atom forms a single bond with the carbon atom. 4 hydrogen atoms singly bond with a sigma bond with the carbon atom, and per the p orbital, unhybridized p orbital laterally overlap forms a pi bond. Okay, in sp2 hybridization, carbon forms sigma bond as well as pi bond. So how many sigma cc bond is there? 1. Only one sigma cc bond is there. How many sigma ch bond is there? 4. 1, 2, 3, 4. Are you clear? Yes. Then how many pi bond between carbon and carbon atom? That is 1. Here is 1 pi bond. And another example, formaldehyde HCHU. HCHU. Here carbon forms a sigma bond with the oxygen atom and a sigma bond with the hydrogen atom. And the fourth, the tetravalency is maintained by a pi bond. Okay, here is now CC sigma bond. Sigma bond with the CO atom 1. Remember that. Here is only one carbon atom, there is no CC sigma bond. The CO sigma bond is equal to 1. And how many CH sigma bond are there? It is 2. 1, 2. This also is sigma bond. Then pi bond is between carbon and oxygen, that is also equal to 1. Okay. Are you clear? Yes. So pi CO bond is equal to 1. So carbon can form pi bond or multiple bond with the carbon atom, carbon itself, or with the other atom. Similarly, CAS. Okay. C double bond S. One sigma bond with the C and the carbon and the sulfur, and one pi bond with the carbon and the sulfur. Are you clear? Yes. Then we move to the sp hybridization. Remember that sp2 hybridization comes, the shape of the molecule is trigonal planar. Okay, the shape of this molecule is trigonal planar. This molecule also trigonal planar. Are you clear? And let's conclude. In sp2 hybridization, carbon forms double bond with the carbon atom or with the other atom. The other bonds are single bonds. Okay, there is at least one carbon double bond, or carbon oxygen double bond, carbon sulfur double bond, etc. One bond is doubly bonded, the other bonds are single bonds. Are you clear? Yes. Then sp hybridization. The next important is sp hybridization. In sp hybridization, one s orbital and one p orbitals undergoing hybridization. sp hybridization. In sp hybridization, one s and one p orbital undergoing hybridization, and the shape of the molecule is linear. Okay, sp hybridized molecules are linear in shape. Let's take an example, C2H2. C2H2. So here a carbon forms single bond, the sigma single bond with the carbon atom. And two hydrogen atoms are also formed sigma bond. And the tetravalency of carbon atom, two pi bonds between the carbon atoms. Okay, So in the case of ethyl, a triple bond with the carbon atom and a single bond with the hydrogen atom. How many sigma CC bond is there? 1. Okay, 1 sigma CC bond is there. How many sigma CH bond is there? 2 bonds are there, 2 bonds. How many pi CC bond is there? It is 2. 2 pi bonds between the carbon atom. Another one, hydrogen cyanide. Hydrogen cyanide. C triple bond with the nitrogen and a single bond with the hydrogen atom. Here the sigma Cn bond is equal to 1. This is 1 sigma bond. And sigma CH bond is equal to 1. Only 1 sigma CH bond. And 2 pi bonds between the carbon and nitrogen. So when Cn comes, you think about it is C triple bond N. Okay, Cn means C triply bonded with the nitrogen atom. So sigma bond is 1, pi bond is 2. Okay, then similarly cyclic compound also. Okay, cyclic compound, sp3 hybridization, sp2 hybridizations are there. Cyclohexane, okay, C6H12, cyclohexane. 6 carbon atoms, each carbon having 2 hydrogen atoms. So the formula of the cyclohexane is C6H12. Then how many sigma CC bond is there? Count it. 1, 2, 3, 4, 5, 6. There are 6 CC bonds are there. All the bonds are single bond, so the carbon atom is in sp3. All the bonds are single bond and the carbon atom is sp3. Then how many CH bonds? Each carbon 2 sigma bond with the hydrogen. So the total number is 12. Okay, the total number of CH sigma bond is 12. Are you clear? Then next is benzene. Another cyclic compound is benzene. I erase this. Benzene. In benzene, the carbon atoms are doubly bonded. Each carbon contains hydrogen atoms, or each carbon bonded with the hydrogen atoms. So double bond comes sp2 hybridization. All the carbon atoms are sp2 hybridized. This carbon is doubly bonded, sp2 hybridized. This carbon is doubly bonded, sp2 hybridized. All the 6 carbon atoms are sp2 hybridized. So the sigma CC bond is equal to 5 CC bond is equal to 3. 1, 2, 3. Then sigma CH bond is equal to 6. 1, 2, 3, 4, 5, 6. Hybridization is sp2. Then sigma bond is 6 sigma bonds are between the carbon atom, 6 sigma bonds between the carbon and hydrogen, and 3 pi bonds between the carbon atoms. So are you clear about to find out the hybridization and number of bonds between the carbon and hydrogen? One more example with the same molecule having different hybridization. Okay. here CH3, CH2, CH, double bond CH, single bond CH, then a triple bond with the CH. Okay, let's number the carbon atom. It is 1, 2, 3, 4, 5, 6, 7. Okay, let's find the hybridization. Carbon is triply bonded, so it is sp. The first carbon is sp hybridized. What about the second carbon? It also sp hybridized. This carbon is triply bonded. Second carbon also sp hybridized. What about the third carbon? Single bond, the other two single bonds. So C3 is sp3. Okay, C3 is sp3. And what about C4? C4 double bond. One double bond, that means it is sp2 hybridized. sp2. Then C5 also sp2 hybridized. Okay, 5 also sp2 hybridized. Double bond between the carbon atom and the others are single bonds. This is C6, all are single bonds, sp3. C7, all the bonds are single bond, sp3. Are you clear? Another one more example. C double bond C. Okay. C H H. This is a special case. Okay, let's number the carbon atom 1, 2, 3. Okay, 1, 2, 3. C1. C1 is sp2 hybridized because it is doubly bonded. Okay, C1 is sp2 hybridized because it is doubly bonded. Then C2 is sp. C2 is sp, pi bonds, pi bonds. 2 pi bond is formed and 2 sigma bond. It is not sp2, it is sp hybridized. And C3 is again sp2 hybridized. Okay, so same molecule having different hybridization. Okay, let's wind up this section. In the next section, we will discuss about the different structures of the organic molecule. Thank you.